Okay, welcome to part 2 of the video. I did remember what it was I wanted to talk about. I wanted to caution you, oops, that should say C, is that some students, when they go to rewrite logs in exponential form or exponential form to log form, will often get confused. For example, 4 squared equals 16. This makes sense to you. 4 squared meaning 4 times 4 is 16. And students often then want to continue writing it in the same format. But please understand that is not what this log means. What this is saying is 4 to the 16th power equals 2. So my caution is this: if these two numbers are next to each other in exponential form, they should not be next to each other in log form. So the exponent and the base should never be next to each other in both equations. So that's why this is a no-no. This maybe will help you understand. All right, so the next part of our notes then goes into terms of evaluating the logarithm. And in order to evaluate the logarithm, I like to say equals x, because this is what I want to do. Right now this is in log form, and I know this is a silly question, but how do I know that this is log form? Well, because it has the word log in it. So let's get rid of the word log by rewriting it in exponential form. So 4 to the what power is going to give me 64. Well, 4 to the first is 4. 4 squared is 16. 4 to the third is 64. So I know that this x right here has to be a 3. So log base 4 of 64 really equals 3. Okay, so number 14, I'm going to do the same thing. I'm going to set it equal to x. So the base of 1/8 to the what power has to equal 1. What's the only way to get a 1? What 1/8 to the what power will make it a 1? I hope you say 0. So 1/8 to the 0 power is going to equal 1. So that means x has to equal 0. And in other words, log base 1/8 of 1 equals 0. Okay, number 15, log base 2 of 1 over 32. So 2 to the what power is going to make this 1 over 32. Now I'm super hoping that you've recognized that this is 2 to something. It's going to have to turn into a fraction. So I'm hoping you remember that this really needs to be 2 to a negative power. So let's see, 2 to the negative second is 1/4. 2 to the negative third is 1/8. 2 to the negative fourth is 1/16. 2 to the negative fifth is 1 over 32. So there we have it. So this has to equal -5. Okay, number 16, 1/25 to the what power has to equal 1/5. Well, when I look at this, I think the square root of 25 will give me 5. And earlier in our video, we said that the square root was the exact same thing as saying to the 1/2 power. So in this case, log base 1/25 of 1/5 actually has to equal 1/2. So that's how you evaluate without using a calculator. And why is it important that we can evaluate without using a calculator? Well, because your calculator only has 2 kinds of logs that it can use. It has a common log and it has a natural log. Common log is a log with a base 10. So it has a base of 10. And we write common log as just plain old log. So when you see something written like this, log of x equals y, with no base written in, please understand that it is a common log, and this is what it means. Log base 10 of x equals y. And the reason this is called our common log is because this is the numbering-based system we use. We use base 10 numbering system in our daily life. The other kind of special log is to talk about the natural log. Last week or earlier this week, we talked about the natural base e. So a natural log is going to be ln, and that really means log base e of whatever your argument is. So we don't want to write log base e every time we write it as ln. That's an L and then an N. And in your calculator, it looks like this. And a lot of you think it's the word in, but it's not the word in. It's LN. And it stands for Logarithmus Naturalis. And it's Latin, and that's where it comes from. That's why it's not NL for natural log, that it's LN for log natural, if you would like to consider it that way. These are the only two kinds of things that your calculator will use. Your calculator only has a common log and a natural log stored in it. Everything that it does with logs is based off of these logs. Well, if you noticed, most of our other previous examples have different bases. So we're eventually going to learn how to deal with that. But for now, we're going to continue simplifying. So it says simplify the expression. I'm going to blow your minds away with how easy this is going to be. I'm going to tell you the answer to number, let me go back to the notes here. The answer to number 17 is 6. The answer to number 8 is x cubed. The answer to number 19 is x squared. And the answer to number 20 is x minus 7. Pause the video and see if you can make some sense of where these answers are coming from. We'll certainly talk about this in class, and then I'm going to have you come back and I'll talk about it in the video as well. So pause the video and see if you can come up with where these answers are coming from. Okay, welcome back. So I'm going to tell you that I'm going to say equals what? And right now I have 13 to the exponent of log base 13 of 6 has to equal something. So if I rewrite this in log form, log base, my base is 13, of my answer has to equal the exponent. Well, take a look. What does this question mark have to equal? It has to equal 6. In question 18, please remember that ln, natural log, means log base e of e to the x cubed. I'm going to say equals what? Equals some question mark. So let's rewrite this. Right now it's in log form. Let's write it in exponential form. E to the question mark has to equal the answer of e to the x cubed. So what's in place of this question mark? X cubed. The same reasoning goes behind number 19. We can say equals the question mark. And it's right now in exponential form. So if I were to rewrite it as log base 5 of the question mark has to equal log base 5 of x squared. Notice everything's the same, and I have a question mark in place of the x squared. So it will have to equal x squared. And again, we've got a common log with number 20. It's in log form, so I'm going to rewrite this in exponential form. My base is 10 since it wasn't written there. 10 to the x minus 7 power has to equal 10 to the what? So 10 to the what has to equal 10 to the x minus 7th power, so that's going to have to be x minus 7. Now there is a shortcut which you need to understand, and that shortcut is this. When you have a base, let's say star, raised to the power of log base star, and let's pick a number 5, that this star and this log base star, they're inverses of each other, so they will always cancel out and leave you with just whatever you have. So let's say triangle, log base triangle of 12. That has to equal 12. Every single time, as long as the bases are equal, They are going to be inverses of each other and cancel each other out. The same works in the other way. Log base star of, let's say, 3 to the, star to the third power is going to just equal 3. As long as the bases are the same, those will end up canceling each other out, and you'll get whatever is left over. With some practice, this will help. With some practice, you'll get to understand logs. And this is your first time learning logs in Algebra 2 ever, so this is something new. It takes some time to deal with logs. Just have patience with it. All right, so this will be the end of video part 2, and it'll be the end of our notes for day 1 in class.